I spent last week with 45 Drives at their 3rd annual Creator Summit, where YouTubers like myself, artists, creators, and industry professionals alike all gather together to talk about the latest in both their art and the storage that helps enable it. As part of the event, I was asked to talk about my workflow when it comes to content creation, and while the talk that I gave was decent, I was also severely jet-lagged at the time, so I decided to turn it into a dedicated video here on the channel, going over how I work with such a massive amount of video content, how I manage it, along with some written instructions on how you can set up something similar. So sit back, relax, fire up your TrueNAS server, and get ready to see how I turn a complete 3-2-1 backup solution into an automatic process that runs entirely without your help. Welcome back to Craft Computing, everyone. As always, I'm Jeff. A common theme for this year, as first coined by Joe from the 30-year New York City time-lapse, was I create data problems. Creators and artists in the digital landscape create tons of data, and all of that needs to be properly managed. That means structuring, organizing, backing up, and making available all the data that helps enable you to do the things that you need. And those concepts definitely aren't foreign to anyone in the business world, but it's amazing how much data a single video production house, a set of 4 full-frame cameras pointed at the New York City skyline, or even an individual YouTuber like myself can generate. A quick peek behind the scenes of what I do here: nearly every video that I shoot is shot at 4K ProRes 420 8-bit. That's around 2.88 gigabytes per minute, or around 380 megabit. And that's not even an intensive bitrate to record at, but plenty for YouTube content that I produce. Now consider my average video takes me around 45 minutes to an hour to film, plus upwards of another 20 minutes of B-roll, along with a ton of screen capture footage for gaming, benchmarks, or tutorials. That's around 230 gigabytes of video per shoot. Some of my more intensive projects have easily doubled that number, with multiple camera angles or longer runtimes. Now there are some YouTubers out there who will keep every bit of video that they've ever shot. If I did that, I'd be looking at a minimum of about 17 terabytes of video per year, or close to 230 terabytes dating back to the start of my channel. I don't do that for multiple reasons. There's no reason to keep every along with quite literally hours of me swearing at myself for fumbling a line for the 8th time in a row. And once my A-roll is edited, there's never really been a time that I've needed to pull up the full bitrate version. I'm not going to be recutting that A-roll into 20 different versions, or even reusing it in videos in the future. As such, I keep all of my A-roll footage around for about a month and then purge it. But I do keep all of my B-roll pretty much indefinitely, as if I ever want to reference a product that I've reviewed or pull up graphics that I've created before, it's nice to have the best quality footage to call back to. My back catalog of B-roll is still nearly 40 terabytes by itself, and that data needs to be kept basically indefinitely. To create videos and publish them on YouTube, I need to move everything that I shoot on my cameras onto a NAS, be able to access the files from my editing PCs, ensure the files are backed up every step of the way, and free up that space on my active projects directory when I've finished editing a video. Most importantly, this process needs to happen without my direct intervention, because if it relies on me moving files around manually when a project is done, being honest with myself means that's just not going to happen. It needs to be simple, it needs to be safe, and it needs to be automatic. So what am I running as far as hardware goes? My storage solution consists of 3 tiers inside of 2 physical servers. Server number 1 is a 45 drives Storinator AV15 and holds both my Tier 1 and Tier 2 storage. This server is accessed directly for both video projects, along with general storage for my home servers. Server number 2 is more for archival storage and is a 45 Homelab HL15, and both of these servers are running TrueNAS scale. Inside server 1, there are 2 storage pools. Tier 1 of my storage is a set of 4 2TB Gen 4x4 NVMe drives running in a RAID Z. That gives me 6 terabytes of usable space with a single disk failover. This is my active projects pool, and really the only storage pool that I interact with day to day. But I'll explain a bit more about how in a minute. Right now, let's focus on the what. Tier 2 is also in this first server and is a set of 8 12TB drives in a RAID Z2. This provides around 72 terabytes of usable space with a 2-disk failover. But while having 2 copies of my data is good, having 3 copies on completely separate hardware is even better. My Tier 3 storage is designed to never be touched, and should only serve as a long-term archive in case my first 2 tiers fail. This storage pool is 8 18TB drives running in a 45 drives HL15 in a RAID Z2, giving me again a 2-disk failover, but with a little over 100 terabytes of usable space. What I'm going to demo today is the solution and setup that works for me with my workflow. But everything that I'm showing is just a standard feature inside of either ZFS or TrueNAS, and can easily be adapted or implemented on your own hardware. I've done videos on a lot of these subjects before, but not necessarily all at once working together. Starting at the top of my storage and going to the bottom, all of my active projects go onto my 6TB NVMe array. There are 2 datasets on this array, one for my A-roll, where I'm recording myself talking like this, and another dataset for my B-roll, screen capture, images, and anything else that I use for video projects. This includes videos that I've taken of products, locations, basically anything that's not just me staring at a camera. So why 2 datasets? Well, I only want to keep my B-roll long-term and delete the A-roll once a project is done. I have 2 different retention policies for how these files are saved, but first we're going to talk about the first layer of protection, and that's ZFS snapshots. Snapshots are a feature of ZFS that keep a record of all changes made to your data. The concept is pretty simple. ZFS takes a snapshot of the storage blocks to save that moment in time. Then, at an interval that you choose, it takes another snapshot and records the changes to any of the block data. This differential can be used to roll back your data between 2 different points. You can restore individual files that changed, restore deleted files, or revert the entire dataset back in time with just a couple of clicks. Best of all, there's no penalty to performance, and the additional storage used is only the data that you changed on that Z-pool. Snapshots also have a retention policy and can be saved for basically as long as you configure them. But there are pros and cons to this setup. If you set, say, a 1-month retention period, you can recover files that have been changed or deleted for up to 1 month later. However, if you intentionally delete a file because you want to free up space on a fairly tight dataset, because that file still exists in the snapshot for a full month, it'll take that full month for the file to truly be deleted and the free space to be returned to you. I have a retention policy of just 7 days on my NVMe pool, as I only use the drives for active projects. Once those projects are completed, I delete the files and move on to the next project. But as such, the files are not removed until those 7 days fully expire, and the last snapshot with that data is finally deleted. But while snapshots do protect your data from accidental changes or deletion, they are still only running on top of a single drive pool. And as you should all know by now, RAID is not a backup. The data on my NVMe pool needs to be copied to another set of disks in order for me to truly have multiple copies of my data. And that brings us to how I actually take backups using TrueNAS. There are 2 main methods of moving large chunks of data between ZFS pools inside of TrueNAS, and those are ZFS replication and rsync. Both are fairly fast and efficient at moving large chunks of data between pools, but they also function quite differently, and have assorted pros and cons between them. Knowing exactly how you want to handle your files will determine which method works best for you. ZFS replication is by far the easiest to set up, as it requires ZFS snapshots to be enabled already, which you probably should have already done if you're running ZFS. It uses the snapshots to both capture the base image of data to transfer, as well as track differential changes for new data. A new replication task will copy your most recent snapshot of your source data to its destination. Subsequent updates will copy the most recent snapshot, and only requires copying blocks of data that have changed. ZFS replication is great for keeping 2 copies of the same data in sync between 2 different Z-pools. But that data is always in sync, meaning if you delete a file on the source data set, the next time the replication runs, it'll also be deleted from the destination. You can kind of get around this, as both datasets will have snapshots enabled, and you can choose to have a longer retention period in your backup pool. But this will still have no way of keeping the data visible outside of mounting previous snapshots, which means it's not great for backing up critical data. Because ZFS replication is a full syncing protocol, I'd rather not use that, as I want to keep my B-roll footage indefinitely. Luckily, TrueNAS also has a built-in rsync function, which is a command line tool designed to transfer files between 2 datasets, similar to Robocopy or Xcopy if you're from the Windows world. Like ZFS replication, it's capable of moving a base set of data and then copying differential changes with each update. However, it doesn't rely on snapshots, instead scanning individual files for changes instead of using blocks of data. rsync can be used for synchronous or asynchronous copies as well, where you either keep every file on the destination or synchronize it with the source dataset and delete any freshly deleted files. Now, unfortunately, the rsync tool built into TrueNAS is really only set up to transfer data between two different datasets, but on two different servers. To run rsync on two local drive pools or datasets, you need to run it as a cron job, and that's in a different menu entirely. For the A-roll dataset, I use the command rsync-a-ov-delete. TrueNAS will scan the NVMe dataset once per hour and copy any new files over to Tier 2 storage along with any files that have been modified, while also removing any files that have been deleted. With my snapshot policy, it takes 3 days for the space on my NVMe pool to be freed up. But I have a 1-month retention policy on Tier 2 storage, so I have up to 1 month to recover any deleted A-roll. And like I said, my B-roll dataset is a little bit different, as I want every file that's ever been created to be copied to Tier 2 storage and then saved indefinitely. And this primarily is why I don't use ZFS replication, because that would remove files from Tier 2 once they were deleted from the NVMe pool. Because I'm not copying snapshot data, rsync copies every new and changed file over to Tier 2 storage, but it also never deletes things from Tier 2 that have also been deleted from Tier 1. I have a similar snapshot policy here, with again 3 days on the NVMe pool and 1 month on my Tier 2 storage. But because rsync isn't deleting any files from Tier 2, my B-roll project files are saved basically indefinitely. But there's one last step in all of this, because once I clear files out of my NVMe pool, I'm again down to only a single copy on a single drive pool. And as you all know, RAID is not a backup. Here I have 2 more rsync jobs scheduled, one for my A-roll and one for my B-roll, but this time instead of copying from my NVMe pool to Tier 2, this is copying from Tier 2 to my 45 Homelab server HL15, which I refer to as my archive. The scripts are set up essentially the exact same way, just across to a different server. My A-roll files are synchronized and deleted from every server as soon as they're deleted from NVMe, and my B-roll stays on the archive indefinitely, even if files are removed from Tier 1 and Tier 2. So I went over a lot of different copy algorithms and if-then statements and workflow, but what does this actually mean for me working with my video files every single day? In all, I really like the way this whole system is designed, mostly because once it's set up, it requires absolutely no effort from me. I copy the files from my cameras to the NVMe pool, and then I edit the video and delete the project when I'm done with it. But in the background, all of those files have been pushed from the NVMe pool over to Tier 2 storage, and then from Tier 2 storage up to my archival, where it's kept basically forever. My A-roll is also automatically deleted once I'm done editing those base files from both Tier 2 and Tier 3, but I have about a month to recover anything just in case I needed to retouch something up. It's a fantastically well-designed system, it works without me thinking about it, and all my data is accessible and secure. Now I know this is not quite a perfect 3-2-1 backup solution, as I'm sure some of you have already pointed out in the comments below. But you have to remember, backups are equal parts security, budgeting, and risk management. A proper 3-2-1 backup system is definitely the recommended standard to follow, and means you have at least 3 copies of your data stored on 2 different forms of media, with at least one of those copies residing off-site. And when I'm actively working on projects, that's pretty much what I have. I have all of my video files stored on the NVMe drive pool, as well as my Tier 2 storage, as well as my archival server on a separate server. But there's a reason I don't have that server off-site. I could definitely buy some cloud storage, or colo my backup server somewhere and achieve a full 3-2-1 solution. But in my situation, there's no real benefit to that. If there's a fire in my garage, or a natural disaster that destroys my home, I'm going to have bigger things to worry about than whether or not I have every B-roll shot I've ever taken. The data that I have here is important for my day-to-day workflow, but if my day-to-day workflow goes away in a fire or a flood, that's going to get interrupted anyway. I'm going to have to restart with new cameras, new equipment, new lighting, new servers. it doesn't make sense for me to invest so much money into doing a full offsite backup when if my day-to-day workflow is interrupted anyway, that data does me absolutely no good. If all of this data is lost forever, life's still going to go on. I'm still going to be able to produce videos. I'm still going to be able to do things. And so you have to manage the amount of risk that your data loss would incur. And with me, it's not very much. I might have some lower quality B-roll inserts because I have to pull them off a YouTube backup or a final video render, which I do keep on a backup server already. But it's not going to be detrimental to my workflow or to my business model. So I'd rather save the money and just run 2 servers in the same rack. So that is a quick glance at how I manage the dozens of terabytes of video files that I generate every year to make videos for this channel. Like I said, most of the video files I actually delete as soon as the video has been edited. B-roll and graphics are kept indefinitely, along with copies of the final render before uploading them to YouTube. It's a system that works automatically, only keeps the files that I actually need, and ensures the files that I do need are accessible when I need them. The thing that I really like about the system, though, is that I achieved all of this with features that are pretty much ubiquitous to any operating system. In this case, ZFS and TrueNAS running rsync. Now, I do wish that TrueNAS would add a custom rsync option, allowing you to set up a local sync between 2 Z pools, but adding a simple cron job works well enough anyway. There are no third-party software, backups, or plugins that I need to use to make all this happen. Backups that I take via snapshots can be viewed and recovered from any OS via a file browser. And because it's all automatic, I don't have to change the way that I work or add steps to an already busy workflow. Full written instructions will be available down in the video description if you're interested in setting up snapshots, replication, or an rsync task on your own system. And you don't need a double NAS setup like mine to take advantage of these features. If you have a similar workflow, you could easily keep your files safe on a single file server with maybe a pair of SSDs for an active project file and a small pool of hard drives to keep that data long term. File management can get quite complicated, but this is a system that I came up with that works for managing my workflow. Let me know down in the comments below if this was helpful to you or how you're managing your files and your backup solutions on your home labs. On your way down there, make sure to drop this video a like and subscribe to Craft Computing if you haven't done so already. And remember, if you like the content you see on this channel and want to help support me in what I do, consider joining the Patreon. Link is down in the video description and gets you exclusive access to my Discord server. And that's going to do it for me in this one. Thank you all so much for watching, and as always, I will see you in the next video. Cheers, everyone. Beer for today is from Evasion Brewing out of McMinnville, Oregon, and it is a little bit of a different one. This is a gluten-free IPA. This is their Hophoria IPA, clocking in at 6.1%. First off, check out how freakishly clear this beer is. That's one of the clearest IPAs I've had this year. All right, we're getting near the bottom of this one, and the remarkable thing about Hophoria from Evasion Brewing is it is a gluten-free beer produced in a gluten-free facility, but you'd never know it by just drinking it. Usually, GF beers have a tell. The reason being has a lot to do with how beer is made, specifically the ingredients that it's made with. Beer loves gluten. Not loves gluten, but loves gluten-containing ingredients. That is wheat, barley, and rye. Those are my 3 favorite plants, and ironically enough, my wife's 3 most hated plants because she has full-blown celiac disease. The reason creating a gluten-free anything that uses actual products like wheat, barley, or rye is because you can extract pure gluten from those grains, but you cannot remove all of that gluten from the grains. What you're left with is some gluten-containing ingredient, even though you've extracted pure gluten from it. So there's really no such thing as a gluten-free wheat or barley or rye drink or food product. So when making a gluten-free beer, you have to substitute your mash bill with some other form of grain, whether it's rice, whether it's beans, whether it's some form of long-stranded protein that will give you a similar result. But the thing is, Similar result is not same result, and there's usually always a taste and a texture difference. This, though, is just a solid West Coast IPA. Like, I'm actually kind of shocked, because I've had a number of gluten-free beers over the years, and they always end up a little bit thin, or a little bit papery on the texture. There's something about it, whether it's an aftertaste or something that hits you right up front. There's always something that turns the flavor and makes it not good. This is delicious. Now, the funny thing is, my wife tried this, and it turns out she hates IPAs, but I think that's more her problem than anything else. But this is an IPA that she can drink, and that's definitely a rarity.